Hi, good morning, good afternoon, and good evening, everyone, depending on where you are joining us from today to us. And I want to welcome my forever best partner, Håkan. Hi, welcome. How are you, Håkan?
Hello. Yeah, I'm fine. How are you?
I am good, thank you as well. And we also want to welcome our speaker today, who's going to be JP. And welcome back, JP. How are you?
Thank you so much. I am well, and you?
Good. That's good to hear. We have met before, actually, a few weeks ago, and we have talked a bit about Translate SQL already. Could you give us, please, a heads up again? What was that about?
Yeah, so initially what we covered was the basics of T-SQL and why it's useful for data scientists to have that in their toolbox. And today we want to show you, or I want to show you how to use it in your toolbox and how to make your life easier when using SQL in collaboration with your other tools.
Mm-hmm. Yes, and it was a really exciting session, and I really hope that today one will be as well. And before going to that session, we would like to give you a quick introduction about AI42, and then we come back to you, JP. See you soon. Hi, and welcome back, everyone. And hi, Håkan. Would you like to start and share with us the motivation for starting AI42?
Yes. So the thing here is that what we would like to do with AI42 is to give everyone a chance to get into this interesting field. So what we've done in practice, we've invited industry experts and recognized speakers. So they will have sessions that we will be streaming 2 times a month on Wednesday at 5 p.m. So we're streaming both to Twitch, to Facebook, and to YouTube. And we started out with mathematics and statistics and probability theory. And after that, we moved into different languages, such as Python and R. And we will also be looking at some different tools like Databricks and Power BI. And then later on, we will also see how can you actually build your own machine learning pipeline so that you can set up your machine learning algorithms and put it into production. And finally, we also have some more advanced topics like reinforcement learning and explainable AI. And in addition to this, we'll also have workshops so that you can put the theory into practice.
Yes, and if you want to hear more about AI42, you can follow us on Instagram, Twitter, or Facebook. And if you want to see our previous sessions, you can go to our YouTube channel, and you can also see the upcoming sessions at the meetup page we have. So with that, we would also like to say a thank you to our sponsors, and that's Microsoft and Miles. So thank you again for giving us the chance. And we also are in a good collaboration with different communities as well. So like the Global AI community and the C# Corner. And we also would like to say a big thank you for making us the amazing intro music for our streams to Mina Marie. And we also would like to say thank you to Levente Pongur, who created our graphics for the streams, the speaker cards, and so on.
Yes, so then I think we can head back to JP.
Yes, let's do that. Hi, welcome back, JP. Are you getting excited?
Yes, always. I'm excited
Good.
when I can talk about SQL.
That's good to hear. Would you like to tell a bit of a few words about what we are going to learn today?
Yes, so today what we're going to do is we're going to take a data set from Kaggle that I've downloaded, the cars data set, and I'm going to take you through the process of how you can use T-SQL to make your life a little bit easier before you start your massive analysis process and exploratory processes when you're starting with your data science process. So I'm going to take you through how to get it into SQL, how to manipulate it, and what you can do with it, and how you can easily change your data to fit the narrative that you want to display.
That sounds really valuable. I can't wait to hear it. Before giving the word and the stage to you, I want to say just a practical information that we are going to share in the chat the link for the previous session of JP. So when you have time, you can review that as well. So you get the whole page, like the whole picture about Transact SQL. And I think with that, I can give the stage to you, JP, if you're ready.
Okay, yes, thank you. So,
Great. Then take it away, JP.
Yeah, just one moment here. We just.
okay, welcome everyone, and thank you for tuning in today. So, what I want to show you is how to use SQL to empower you to get your data analytics skills and data science skills up there. So to start off, in the previous session we spoke about there's many different flavors of SQL. You get MySQL, PostgreSQL, Oracle SQL, but I get excited when we talk about T-SQL, which is the Microsoft flavor of SQL. But to keep in mind is if you understand T-SQL, you will it's 90 to 95% overlap with all the other flavors of SQL because they're all relatively aligned with the ANSI standards. The reason why I'm pointing you there is with PySpark and PySQL and Databricks, you can use a lot of SQL syntax in there as well. And you can take the principles that I'm going to show you here today to apply that in your whichever application or platform you are using, preferably T-SQL. So what I want to show you now is there's a couple of different versions. So if you want to get started and want to play, you won't be able to play along today, but if you want to go and play afterwards, you can.
JP, just one thing here. Could you hide that sharing dialog from StreamYard? Because right now it says StreamYard is sharing your screen. Yeah, thank you.
Okay, not a problem. So there's a couple of versions of a SQL Server that we can quickly just run through. First one is the enterprise offering. It gives you a lot of different functionalities, and most organizations will go with the standard edition. But if you want to go and play along, you can either go and download the developer edition, which has all the bells and whistles of the enterprise edition. You're just not allowed to use it in production workloads. Or I have on my machine the Express edition. It's a lightweight SQL Server edition with a little bit of restrictions. So your database can only be a certain size and you can only have a certain amount of memory. But this is perfect if you're just playing around and exploring your data on your machines. So once you've decided which version you want to work with, or if you're lucky enough, your organization has already an environment where you can play or that you can go into, because you can also spin up different SQL Server instances in the cloud, in Azure or AWS. But in Azure, you have also a few different options. But now that you get that, so if you just want to go and download the SQL Server Express edition, you can literally just go and Google it. And the very first link that comes up will take you to the Microsoft download page and you can install it. Microsoft has made the installation process super easy. So once you've downloaded it, it's just a next installation and you are almost ready to go. The next step is you need an environment to start working in. So for today's exercise, I'm going to take you through the Azure Data Studio, but I do recommend when you go and download a environment to work in, go and download SQL Server Management Studio. It is it's a more complete package, but the very nice thing is also you can just go and say download SSMS, SQL Server Management Studio, and the very first link that pops up will take you to the screen to download it. And again, this is a very easy installation. It's a next installation. The beauty of going this route is it also installs Azure Data Studio for you as well. which is quite nice because that is the development environment that we are going to focus on today. So let me take you through a quick tour of Azure Data Studio. So in Azure Data Studio, you have your connections. So you'll see I have connected to my server, which is on my local machine, my SQL Express edition. And if you go down, you'll see your databases. I've created a nice little AI42 database specifically for you today. And it's as simple as you just type the syntax create database in your query window, and you give it a name AI42, and you run this piece of code. But I'm not going to do that right now because we've already created one. You can also create notebooks, which is a little bit more familiar to a lot of people if you've been working with Databricks or Spark or even Jupyter notebooks. And you can also then search through your files. There's some source control integration, which is nice, and Azure integration as well. All very nice bells and whistles that we can use here. But so we care about the data today. So I have downloaded a CSV file with the cars data set. The one with the make, model, horsepower, where we all try to, in the past, predict the fuel consumption of these vehicles based on different parameters. So now I have the CSV file. How do I get it here? How do I start querying my data set? And that is actually, there's one of those questions, how long is a piece of string? And because there's so many different ways that you can go to it. My favorite is if you just use the import-export wizard. If you have SQL Server Management Studio installed, you can just search for DTS, and it will bring up the SQL Server import and export wizard. Once you click there, it will show you this nice little page. You can go next. On next, you can give it a whole list of data sources. But for our purposes, I'll use flat files as a source. And if you go and browse for that file, see there by default, it always selects text. So I know it's a CSV, or you can just say, show me all the files. There's my cars data set, my cars.csv. So if I click it, I have a few couple of parameters that I can set. What is it? Delimiter, text qualifier, skip rows, is the column name. It's in the first data row. I can go to the left and say, show me all the columns. So yeah, I have a little bit of a preview of what's in my data set. And if I go into advanced, I can set advanced functional features. So by default, the import-export wizard will always set all your fields to a string data type and 50 characters. And then you can preview it, and you can click next, and it will, when you go to next, it wants to ask you where should it go. In our instance, we would like it to go to SQL, and you have a drop down showing you if you use Windows Authentication, it's authenticated automatically against my local instance. And on the database, you can select where it should go. So I've created my AI42 database. I go next, and if I click next again, it will import the data for me into SQL. But I'm going to stop right here because I want to show you the way that you can do it in Azure Data Studio, which is a little bit more intuitive. So if you've created your database in Azure Data Studio, can go and right click on it and click on Import Wizard. It will bring up this nice little wizard for you that you can also select which server, which database, and where's my file. So again, select my cars data file. The difference here is it by default allows you to see CSV and TXT files. Not a biggie, but it's just a nice to know. When you go next, it shows you also a preview of the data. But this time, what's a little bit different is this import flat file wizard took the liberty to analyze the top 50 rows in my file and try to predict which data types all of my file fields are. So you'll see it says wheelbase as a float, engine size as a small integer, and my compression ratio is. So I know for a fact that my horsepower, peak RPM, and price fields will result in an error because there's unknown characters in there that does not fit into an integer field. But just to show you, if I select import data, it comes up with this big scary error message, which you don't need to be intimidated with, because the very first line tells you it found a question mark of type string and it cannot convert that to a number in the price column. And if I were to go and change the price column to a varchar, which is a text field, because I don't know yet what it is, and I go and click import again, I get another error. On this, now this time it's telling me on horsepower. So if I go to horsepower, and I know peak RPM will also throw errors, so let's just fix everything once off. Okay, and it has successfully inserted all my records. That is nice. Okay, done. Now what? So now I can go into my database, I can go there and I'll refresh, and I said, there's my cars table data set that I've just imported. If I open it up, it gives me a little bit more functionality to go and dig a little bit deeper. And I want to see how many columns there. What's the columns? In my columns, I can see all of this was imported and the data types, what was assigned. So let's start looking at the data. So step one. I have a query window open here that's connected to my AI42 database. If you want to ensure that your code always connects to it, you can, in T-SQL, you can use the use function, and you can tell it use AI42. And if you run this piece of code, it will just automatically push you into the AI42 code database. This is not necessary, but it's good practice to always specify in which database you want to work. Now I can go and, as a extremely bad practice, say return all the fields with my select star, return all the field columns and all the records back from my cars data set. But because I've never worked with this data, I've never seen it before, I would highly recommend, if whenever you start, to just limit your data set to only return X number of records, because it's not uncommon for a data set to contain millions or billions of records. And if you do a select star from that data set and there's a couple of billion records, it can kill your company's network or your machine. There's a lot of drawbacks. Then, if now I have multiple statements in my query window here, and I only want to execute this portion, I can go and I can remove this, but it's also not needed, because in SQL, whatever you select, you can run this and it will return the results for you. I'm just going to minimize the pane on the left-hand side so that we can see a little bit better. So now I have told SQL to go and fetch 10 records. You can see 1 to 10 records from my cars data set and return all the columns that it had. You can see all the columns. Now, if you remember, when we were trying to import it, there was a couple of, there was 3 columns that was giving us issues. And I want to go and have a look at those ones out. So I remember it was my horsepower, and the error said there's a question mark in there. So I want to see what records have that question mark in there. So what I can do is I can write my where predicate, as discussed in the previous session. So to filter down, so I'm giving it now our column, and says where it's equal to that question mark. And to be safe, I don't always know if it's just a question mark or was it a space question mark. So what you can do is you can do an L trim and an R trim. So just what I'm telling SQL now is remove all the white spaces in front and at the back of my horsepower column, and then go and search for a question mark in my data set. When I run this, I get 2 records that is returned. Horsepower, and there you can see both of them have question marks there. But I remember there was also in price. I also had an error when I tried to do it on price. So I can do this exact same statement, but now I can tell it or in the price column. So now it will go and look for everywhere where there's a question mark in the horsepower column or where there's a question mark in my price column. And now I get 6 records that is returned. So I have 4 records that have a question mark in price, and I have 2 records that has a question mark in the horsepower field. The one thing that I can't say for sure is that this was my only anomaly in these 2 columns, and I really, really want to change these 2 columns into numeric columns so that I can perform calculations on it. Because at the moment I can't sum everything there together. I'll run into errors because of this that is not of a numeric data type. So what I would like to do is, let's see, is there a way for me to change to fail this column, so return this value, but if I can't convert that to a numeric data type, then just make it a null. Now the null concept is it's the absence of data. It means it's not a 0. It means there is no data in that specific block. Why that is important is if you have 4 columns with where one has a null value in it, your average is only divided by the 3 that has values. Where if you have a 0 or another figure in there, it will always be divided by 4. So that would skew your results. That's why I want to ensure that everywhere where it's not a number, turn it into a null because I don't know what the data is. So what I can do is I can say after bring me all the columns, put a comma, and now I can specify anything that I want. So what I'm going to try here is return the horsepower column back, but cast it as an integer. I want to see if this will still fail, and this will now fail because of this question marks. It can't convert a question mark into an integer. Now, one of my favorite functions in SQL, SQL Server, is the try method. So you can do a try cast where you tell it, try to convert this into an int. If you can convert it, then do it. If you can't, replace it with a null. So now when I run this, you will see, if I go to the very end, so I've now added a new column in my next to price, which is representative of my horsepower, but instead of having my question marks, I have nulls. So I would like to call this column horsepower 2 because currently it does not have a name, or horsepower fixed. And how you do that in SQL is you give it an alias. As, you type the word as, and then what you want to call it. If I run this again and scroll to the very end, you'll see that I have a new column called horsepower fix. But what if that's not, or what if I want to change it in a total? I want to fix the columns that I have currently. Now, what is a very good idea to do is go through your data and understand it, and look at your data and try to figure out what you want, what you need, and what you don't need, so that you don't have to do a select star, only return what you need to. So what I'm going to do now is, let's say we take this concept, our try cost, and do that in my where clause, and just tell it to say, try to cast it as horsepower. If not, then it will return a null. If it does, check where it is a null. So this will allow me to see where there's other issues in my data as well. And I would like to do that with the price, my price column as well. So again, I will only get my 6 records back where there's those issues. Now, I know for the purpose of what I'm trying to do now, I only require my ID column, which is currently named column 1. So what I'll do is I'll remove this top 10 star. I'll tell it bring back column 1 and call it as my car ID. That's what I want that column to be named. And after that, I want to see the make of the vehicle. And now I want the horsepower. To return the horsepower and the price. Okay. As I mentioned earlier, that you can alias it and give it a name, because I'll show you now with the price is I'm not going to alias it, and you will see that the very last column is just an unnamed column. So let's give it a little bit of an alias, and now we have a nice little data set fixed where we can start doing aggregations and calculations on top of it. So now I can remove my where clause, and I can start having a look at my data sets. So but this is still temporary. I've just fixed the data when I'm looking at it now. I haven't fixed the source of my data. So how do we go about fixing the source, our source data? And that's actually quite simple. Is what we'll do is we'll go and issue the update statement, which we did also cover in our previous session. So what you'll issue is you'll write update statement, and then you'll say, I want to set the price column equals to what our next action is going to be. So in this case, I want to say, to do this to it and say, if you can convert the price to an integer, then leave it the price. If not, make it a null. And I need to do that for my horsepower as well. And so horsepower. So horsepower equals this method, and you can do the very same with our miles per peak, or our peak RPM, which was also giving us an issue. Now, what the word of caution that I want to issue here is, if you are working on any sort of production system that you do not own the underlying data, that you did not import it yourself, I would highly recommend against using the update statements. And if anybody else is going to work on your data set and they need to perform their own data cleansing and their own processes, also do not do the updates. And then as a extra safety caution, if I run this will update every single column with the name price in this data set. But we know there's only a few that has an issue. So what you can do is, in your update statement, you can issue a where statement, and we can say where the horsepower equals that question mark, and only update those fields for us, those records. Still not my favorite way of doing it, because it feels like I can't check. It's writing code, run it, and then the action has been performed, and I can't back out after I've done it. I need to start from scratch again. So my favorite way of doing that is to start off with your select statement. So select all your columns, from your data set and specify your where clause to find all your dirty data. And we've been going through this data set now quite a lot. So you'll see this is our 6 records that is problematic. What I've done now is I've aliased our data set. I gave it an alias as a cause. The reason why I'm doing this is I can now replace my select statement with an update, and I give it my alias of X. And in there, I can now create my set operations where we want to go and set our horsepower, our peak RPM, and our price columns. But now I know I will only apply to these 6 problematic fields. If I run this, I get a message that tells me 6 records has been updated. Where if I were to do the previous method without our where clause, where I just say update my cars with my horsepower peak RPM with this, if I run this, 205 records was affected, and now I can't. If I made a mistake and I by accident did not specify one of these fields correctly, I lost that data, which is obviously not ideal. So now I've fixed my cars data set, and I've brought it, I've cleaned it up as I need it. So what now? So no, it's very, very unlikely that all the data that you'll ever need for your analysis sits in one data set. It's a very ideal situation if it is, but it's very unlikely. So in this instance, I have a manufacturing details lookup table. It's just a small little table that have a specific manufacturing code for each of these brands of vehicles that's in my cars data set. Now, if you look at our cars data set, you will our cars data set. I have this the make column in this data set, and I have the exact same in this data set, my make column. One of the things that you'll notice in my manufacturing details, I have alpha space Romeo, and in my I had to pick the most difficult name. And in my cars, it's alpha dash Romero. And what I would highly urge everyone to go and try is go and fix this. Go to write your update statements and go and fix this in your cars statement, because in this scenario, your manufacturing details data set does not belong to you, so you can't make updates to that data. So how do I get my manufacturing code into my cars data set? Because I want to start sort of building reports and doing analysis on the number of doors different car types, car manufacturers and body styles have. So the best and easiest way to do this is I always like to give all my tables a nice little alias. So I'll select my manufacturing details as my as MD, and then you can write an inner join, because if there's that famous diagrams, the Venn diagrams of how inner join, outer join, left join, which we all covered in the previous session, is taken up earlier. So I want to join my manufacturing details to my cars data set. And I need to tell SQL on my cars data set, there's a make column, and on my manufacturing data set, you can see I'm using my aliases now, there's also a make column in there. If I run this now, you'll see I get my make, my manufacturing code, my ID, and then my make again. So here you can see the first two columns is my manufacturing data set, and the rest is my cars data set. So now I know what I need, but now I need to start trimming it down again, because I can't have the same column named twice, because that could cause issues in the next phase of my analysis. So what I want to do now is I have this data now. So let's say I understand the manufacturing code. I don't need to have the make in there. I want to look at my field type and the body style of my vehicle. Those are all columns that I know I have. But also, now I need to, like we discussed, I need to start understanding how many doors does each car type have. So I have my column number of doors, and here you can see the data is 4, 2, 4, and it goes on like that. And this is not ideal because I can't tell SQL to sum up this or sum or aggregate this because it doesn't know what to do with this because it's not numbers. So I'm going to apply another method that we briefly touched on in the previous session is our case statement. So what I'll do here is case my number of doors field. So when I have the word 4 in there, then return the number 4. When I have the word 2, then return the number 2. And you can go and look into it deeper and scan through your data. If you want to, you can do a little group by, so you can have a quick look at your data. So let's say this bring back all the number of doors, and give me a count, tell me how many of each there is from my cars data set, and then obviously now I'll need to give it a grouping of my doors. So what this will do is it will just tell me, okay, so I have 114 vehicles that has 4 doors, I have 89 vehicles that has 2 doors, and I have 2 vehicles that I do not know. So in that instance, I know now that I can say if it's not 2 or 4, then it's an empty value. And the case statement just has to be ended off with an end. And let's alias it with the name we started off with. So now, if we run our data set again, I just need to spell the number of doors correctly. We get back our manufacturing code, our field type, our body style, and our number of doors in a numeric feature. And this is now super useful. Now we can actually start working with this. But if this is something you need to do to your data every single time, and this is data set you're going to continuously use and go on with, I would highly recommend let's create a view around it. So we did touch briefly in the last time on a view, but a view is essentially, if you think about it as a window in real life. If you make any changes and stuff, you look through the window, but you're not making any changes to what's on the other side of the window. You can position that window to only look at what you need to look at, and that's essentially what we want to do here. I'm going to create an empty shell of a table with my little query that I've written. So I can say create view with my executive, and I call this now my executive overview data set. So this is how I want to report this to my executives. So once I create this view, which I've already created, we have a very nice little functional feature that I can now say select all from this view. And now SQL will see this as a table. And now I save myself from writing all of that code over and over and over again. What can I do with that now? Now I can start doing my aggregations and make my code and my life a lot easier. So I have my manufacturing code, and I want to, I need to report or show or figure out how many doors the average different body styles for different manufacturers have. So what I can do here is I can say, do my return the average number of doors for me and create myself a little set of my manufacturing code and my body style. So I'll need to bring back the group by function and paste in my manufacturing code and my body style. If I run this now you'll see for this manufacturer, their convertibles on average has 2 doors. If you scroll down, this manufacturer on average their sedan have 3 doors. So this is something I would then go and investigate. Is it a sports manufacturer? Why did they only have 3 doors on their sedan? So now I've quickly picked up if there might be anomalies with my data that I want to fix before I start with my feature engineering process or my analysis on my next phase. So, and this is now a little bit confusing. So let's say I understand my manufacturing code because you, as a data scientist, you are the subject matter expert. So let's say order by my manufacturing code. What it will do now is still do the grouping, but show me my manufacturing codes in a nice ordered fashion so that I can quickly have a look and say, I know this manufacturing code and I understand their sedans is only 3. That's because they do have the wagons and the hatchback. You would know because you understand the data that you're working on. Now that we have this, I want to actually write a little query to bring back my body style. To just tell me how many body styles have an average of 4 or more doors. Now this gets a little bit complicated. So either we can turn this into another view, but we might never use it again. So instead of creating a view, we can do what's called a common table expression. So in SQL Server, in SQL, you have this nice little function or feature where you can tell it, you say width, and you give it a name. So this is my temp data set that I've created in this view, and I'm just saying as open bracket, and I'm running my. So now I just need to ensure that all my fields have a name, or all my columns have names. So I'm just going to call this my average number of doors. Right below this, I can now do a select star from my temp data set, and it will return the exact same data set for me, but this is now a temporary little view or temporary data set. The power of this is I can start with filtering on this a little bit more. So I have a column with average number of doors. So let's say where my average number of doors is greater or equal to 4. And if I run that, you will see I have my result set has gone down quite a lot because now it's only sedans and wagons. And what I really wanted to look into is what body styles only have an average of 4 more doors. What I can tell SQL is bring me back a distinct list of body styles where from this data set where there's more or equal to 4 doors. If I run this, I now know only sedans and wagons have an average of 4 or more doors. Then, just to round us off at the very end, so let's start very quickly with selecting all from our cards data set. And I now understand the data. I know that my make of the vehicle is important. I understand that the field type is important. I understand that the body style is important. And let's say the city miles per gallon is important. I return this data. Okay, great. So let's see. I want to get a rank of the vehicle that is the most fuel efficient on city miles per gallon. So there's a concept of ranking functions in SQL with windowed functions. So what we'll do is I'll tell SQL, I want to create a rank. So you call a function rank, and you tell it to partition it by my make. So I want to see the most fuel economy vehicle by make. and I can rank that by my city miles per gallon, ordered by city miles per gallon, and this is descending, so not ascending, descending. If I run this, you'll see I have my alphas, which is these two are rated the worst, and this one is then the best. So I have 1, 1, 3. So what if I don't want to look at it? This I wanted to show me 1, 2. There's another function that you can use that's called the bench rank. And you can go and read up on it, and I did cover it in detail in the previous course, all the theory behind it, with all the links on where to go and find it. So if you run it this with bench rank, you'll get 1, 1, but the next is 2, no longer 3. And as a very last bonus feature is you can use the row number feature. Row number just counts 1, 2, 3, 4, 5, and you'll get 1, 2, 3 on the window, and my very next window, when I move over to Audi, I start at 1 again, 1 to 7, because I did tell it partition by the make. So every time I reach a new vehicle make or manufacturer, I start over. You can see that same concept has been applied to the ranking, the bench rank, and the row number. Now, the row number function I do use on a daily basis because it's probably the easiest way of identifying duplication in your data. You can call the row number function and say partition by, let's say in our case, we have our column 1, which is our ID field. And I'm pretty sure that in our data set there is there's nothing other than a 1. But if there is, I can use my common table expression and create myself a quick deduplication piece of script, so which I can just say select star from my dedupe, where let's call this my row number column, where my row number column is not 1. You can also say not in this file, in this syntax. If you run this, I have no duplicates in my data, I am good to go if I consider this my determining factor of duplication. If I made it make and body type, so you can have 2, 3, you don't have to just have 1 column in there, you can have multiples, and there I can see all the instances where I have multiple Alfa Romeos, which is of body style convertible. So if that was my determining factor, that is my duplication. Thank you very much. Can we open up for any questions?
Hi, and welcome back, everyone. Wow, JP, thank you for the session. It was really, really valuable, and we got some comments also that it was very practical, and it was really nice. So thank you a lot.
Oh, thank you.
So,
Yes.
do we have any questions?
No, as you said here, we had some question or some comments here from Pradeep, who says that it's a very interesting session. And we also have from Steven Simon. He also says that it's a very practical session. So I think that people have been enjoying your session, JP, a lot.
Yes, and it was actually practical because you've shown us a lot of great ways of preparing the data for an easier overview and like how to clean it up and such. So it was really interesting. So thank you a lot. Håkan, do we have any questions ourselves?
Yeah, well, maybe did you mention what are some good basic data sets that you can start off with if you want to start off right now with something? What is a good data set that you can start playing around with?
I would highly recommend if you go onto onto Kaggle and go and download the CORS or the IRIS data sets. The reason for that is there is hundreds, if not thousands, of tutorials on how to um, teach yourself data science or data science courses that use that as a basic. So if you start familiarizing yourself and start playing around with these data sets, it might make your path forward a little bit easier because look, it's always good to learn new to get the skill to understand and deep dive into new data sets quite easily. But when you just start off, I would recommend familiarize yourself with one or two or three very famous data sets and use that across the board, because then you've learned the functionality and the syntax instead of the data.
Thank you. We got a new question.
Yes.
So, hi JP, what is the main benefit for moving to Azure from on-prem?
Okay, so that's a fun one. So moving to Azure from on-prem, I prefer it being someone else's problem, my patching and my hardware. That is essentially what Azure is for, because Microsoft ensures that your system is always up to date and you no longer have to care about the hardware. To give you an example is, in the organization that I work with, we cannot keep our hardware for longer than 3 to 5 years. Then it's out of warranty, and then we have to replace or buy new hardware. And that ends up to be quite a task. And not just on hardware costs, but you need a full-blown IT team and infrastructure team to replace and migrate and manage those services every few years, and you need a support team to be on call to ensure everything is up and running and patched and all of that thing. Where if you move to Azure, more than 80% of that is being taken care for you. So that is something that you also need to take in consideration when you start do cost calculations.
Yes, that's a really good answer, actually. Thank you. Do we have any other questions? Now you can still post it in the chat so we can answer them.
And we can also say that for those of you who are watching this, on afterwards, that it's always possible to ask questions in the comment box and in the comment section, and then we will follow up and take the questions back to the speaker and get back to you. So that's always a possibility. So yeah, it looks like everything is crystal clear.
Yes,
Okay.
it seems so.
Thank you very much for the opportunity.
Yeah, thank you so much.
Yes, and thank you everyone for joining us. And if you would like to hear more about our sessions, don't forget to sign up to our meetup group. And also, if you would like to see our previous sessions, we also shared the last Transit SQL session in the chat, but you can also go to our AI42 YouTube page and you can find all the recording there too. So with that, we are going to say a big thank you to JP, and let's see, when do we meet again?
Yeah, we meet again actually in 2 weeks' time, and then we will have Seth Juarez, who will talk about machine learning. So that will be a very, very interesting session.
Yes, that sounds really cool. Finally, we go some deep stuff. Nice. All right. So then let's meet again in 2 weeks. I hope all of you will join us again that time. And with that, I want to say thank you again, JP, for joining us. It was really a valuable content you've shown us today. And thank you, everyone, for joining. I hope you also enjoyed it, just like us did.
Yep. Thank you so much.
Thank
Bye-bye.
you. Take care.
Bye-bye.